Hello and welcome to the channel. Today I want to show something off that I've been working on for about a year now. I've been working on it and I've been putting it aside because I just couldn't get it to work. And just quite recently I was pretty sick with the flu, and from sheer boredom and despair of not having anything else to do and not being able to get out of bed, I took a look at the code that I had written for this thing, and I stumbled over some things that I apparently did wrong and never noticed before, and I thought I'd give it another shot, and it appears to be working now. And the whole thing is actually not only this simple control unit here, which is an Arduino and a LCD and keyboard pad, but much more than that. It's actually my do-it-yourself Sandwich Toaster Reflow Oven. Now, this here is a sandwich oven. It cost exactly 39 euros. It's a pretty neat little thing. It has 800 watts of heating power. You can select if you want to have top and bottom heat, top heat, or if you want to turn it completely off. It has a time dial, which is pretty nice. If you put something in there and you forget to turn it off, it will turn itself off after a preset time. And the last part of the whole thing is my little control box that I've been using for the SSR Arduino dimmer. There's an SSR relay in there. It's pretty nicely protected. It's got a 10 amp fuse. It has a lot of space, so it's probably gonna get some new features pretty soon. But let's talk about the toaster oven for a second. Now, this is really cheap, and it's also not entirely finished, but there's a lot of room in there, enough for a graphics card or some PCBs that you want to solder or reflow. You can use this for soldering. You can use this for reflowing. I've used it for one or the other graphics card that needed a go-over. Right now I've got this K-type temperature probe, which I'm feeding in from the front. I'm going to change that. I'm going to drill a hole in the side, and I got to find a way so you can actually still place the probe where it works best. Sometimes you want to actually place it on whatever you're reflowing in there. And by the way, it also makes excellent French fries, absolutely excellent, for the sheer fact that you can actually tune it to the exact right temperature. The control software is, hey, it's done. Let's let it run a bit. The control software right now is in preheat mode, which means it's trying to get the chamber up to 40 degrees Celsius, which is a good starting point. Basically, it's not as cold as my basement is, and you're still not burning your fingers anywhere. I so far implemented a small set of programs. For example, there is the simple heat program, which is preset at 150 degrees. There is a PWM for the heating. There is a PID for regulation of the temperature inside the oven, because the whole heating is quite slow, and it's pretty easy to overshoot your targets. And The PID was actually the place where I had gone horribly wrong when I programmed the thing. I got the whole D part of the PID, the derivative, I got that completely wrong. And I feel kind of bad about it because I actually bought a book about PID controls, and I was pretty sure that I had it right. As you can see, it's heating up very fast. This is one of the reasons why it's so good for doing reflow jobs, because you want to do a reflow in a certain manner where you preheat your board and the electronics and all the soldering spots. You go to a safe temperature where the solder is not yet melting, and then you very quickly push for the temperature at which the solder will very shortly melt, settle, and then you want to dive back down again so it can solidify pretty quickly. And to actually achieve that, you need to be within 2 to 4 degrees per second. And this little oven with its 800 watts of heating power can actually achieve that, which is very nice. As you can see, we've already passed the 150 degrees. It's going to settle now, and it will hold the 150 degrees very nicely. There's still a little bit of overshoot. I'm still working on getting all the parameters just right. But for a start, it's working very nicely. As you can see, the second probe that I've got here is reporting a temperature that is a little bit below that. First of all, because right now that second probe is deeper in the heating chamber, and the primary probe is closer to the heating coils. But this will both settle, and in the end it will just achieve the right temperature, and it'll hold it. I've also done a lot of tests with this thing over the time while it was not correctly working, but it's a lot better now. And we can actually let this cool down for some time and go back to preheating, which is 40 degrees. It will turn itself off completely. And let's give it a few minutes to cool down. Okay, while this is cooling down, let's go over the components that I used for this. Number one is the Arduino and the DF Robot LCD and keys. There is a Max 6675 decoder that the K-type probe is connected to. And there's the solid-state relay, and basically that's it. There are no more components in that, except for the toaster oven and a bit of cabling. Okay, this has cooled down enough to show this next thing. I will actually let this thing pass through a temperature curve. Since it's already heated up, we can start the process just now. And it's going to step through several temperatures to actually get a PCB or any board in there. Firstly up to temperature, then it's going to take it through the soaking phase, and then it will very quickly rise up to 250 degrees Celsius. Hold that for 10 seconds and switch itself off, letting the temperature drop fairly fast. Let's watch. Now we just hit 100 degrees. It's now slowly rising to 120, where the soaking phase will start. It does this with 2 or 3 steps in the middle, because it's actually better that way, because you have a little bit of training for the PID algorithm, which will kind of calibrate itself, so it can hold the temperatures a little bit nicer. I actually took some measurements and made some graphs from the temperature movement, and it is very close to what the usually attempted temperature curve would look like. Only the soaking phase is a little bit longer, but that's not really a problem. So it will now go stepwise from 120 to 155 degrees when it will start the actual soldering run. This works very well for boards, and I've also used it, for example, for some chips that I've taken off, to actually reball them, or basically to get new balls to stick down properly. That worked very well. And still makes French fries, which is pretty neat, but after doing a few PCBs, it's better to actually put something on top of the French fries so they don't get too much atmosphere from inside the oven. I gotta try popcorn someday. That's probably the next thing that I'm going to try out. As you can see, it's slowly rising up. It will do this as slowly and carefully as possible, not to overshoot too much. This takes some time, and every time that it's actually reached one of the steps, it will hold at that step for 30 seconds and then go to the next temperature. All in all, this takes a while. So when it's reached 150 degrees, it will end the soaking phase, and it will go for the full throttle run up to 215 degrees, and that will then end the soldering. As you can see, we're now above 215 degrees Celsius with both sensors, and after 10 seconds it will just turn itself off. I'm still thinking if it's possible to add a fan which will cool the chamber, but from the experiments that I've made until now, this doesn't seem to be necessary. This is working very nicely. The temperature is also dropping at a pretty good rate now, which is about 0.5 to 1 degrees per second. It shouldn't drop any faster than that. At about 180 degrees, it's actually safe to open the door of the oven and wait for it to cool down completely and then remove the boards. And the tests that I've made look very promising. The only thing that is not as well as I would have liked it is if I use flux, I do get a fair amount of smoke and vapor, and I have to take care of that with my soldering air remover, and that works okay, but it could be better. But for 40 euros, I'm prepared to just let that slip. Maybe just to explain this, at the beginning I said that this was a PWM that was controlling the oven. This PWM is not what most people would consider a PWM. It has a period time of 5 seconds, so if I want to turn it on 20%, it will be on for 1 second and then it will stay off for 4 seconds. But the heating coils in the oven are so powerful and heat up so quickly that this works very well. And right now I'm not going to change it. I'm not going to use a high-speed PWM or anything like it. This works very nicely. So, for those of you who are interested, I may be posting or giving away the code on the Arduino. It's not pretty. It's yeah, it might need some work. You can get these ovens pretty much everywhere. Make sure that you have one which has a lot of power. Don't use a microwave, and get yourself one of these nice high-powered SSR relays. They work very well, but make sure that you put it away safely. Like in my case, in an old ATX power supply, I'm using the old cord and just put a Euro plug in the back of here. But everything is nicely packed up. It's pretty safe, even if this thing should explode. And they are known to explode. I'm pretty sure that nothing will get out, and I'll be pretty safe. Anyway, I've got good fuses in my house. So, I hope you like this. Thanks for watching, and bye-bye.